Alright champions, so in regard to this rectifier switch, Achilles' comment in the previous video was it's not mounted correctly, it's not supposed to be mounted like that, I think was the way they phrased it. So one could maybe assume that it's supposed to be mounted 90 degrees to that way to avoid that lip, as opposed to relying on a nut that's not even on the switch, just spacing the other side of the body of the switch. Now looking carefully down there, you can see that thread is right up against, if not slightly cut into that lip, so there'd be no room for the nut there. And this is Achilles' own label, clearly showing the rectifier switch operating from left to right from the rear view. You got like 6mm of leftover thread there. They could have just drilled the hole like 2mm to the right and then just put a nut on the inside with a lock washer, no problem, and then you'd have less thread exposed too. It looks a little nicer. But anyway, let's just fix it and move on. We've got the existing hole to contend with, but it's also very tight down there. Won't be able to use like a power switch like that one because it kicks off at a right angle. It'd have to be a similar switch, which brings with it probably a similar rating. And anything bigger, we'd have to drill another hole. That one would just be sitting there unused. So yeah, very, very inconvenient. If they had a hole in the center of that sort of area, might be able to fit a switch with a slightly larger body in there for a higher rating, but yeah, it's very difficult to find a good solution when things are like this. Alright champions, I'll show you the work in a sec, but we've got her up and running and stable. Now in the valve rectifier setting we're pulling about 84%, and in the solid state rectifier setting we're pulling about 105%, so I might change that 560 down there to a 510, make it a bit hotter in the solid state than we'd prefer, but you know, the original champs used to run about 120, 125%, but that'll bring the, when it's set to the valve setting, that'll bring it up a little bit more healthy. So sort of want to go plus minus maybe 10% of 100, depending on what switch you are. You can't really set it up perfect for both of them, so you've got to find a compromise between the two. We've got the new Taddy in there and the existing rectifier. I did notice a little bit of flakiness floating around in the glass, so I don't know how long that one is for this world, but it does have backup diodes and there's always the option of bypassing it down there, so you know, worst comes to worst, you can still finish the gig on solid state mode. Now I've reused these turrets so we can replace the components more easily. Instead of having them wrapped around the bottom of the post, we've just got them popping through the top there, so it's very quick and easy to swap out these components. We've got the new bias cap down there with a little dab of silicone against the existing cap just to stop it wobbling around. In the rectifier switch situation, although not ideal, what I've done is I've put a higher rated switch in there, higher current rating, and it's a dual pole dual throw, so I've paralleled the two poles so the current is shared across the two poles. And there's my phone. Every time I press record, my fucking phone rings. So I just had a chat with the customer, and he's happy with that rectifier switch because he pretty much just leaves it on valve rectifier all the time. And I just told him if he is going to switch it over, just maybe flick off the amp first, just to avoid any arcing potential there. I'm probably being super conservative. It's a small amount of current, moderate voltages. So we talked about the drive switch. Now I've got a 1 meg resistor in parallel with that switch, and all the popping's gone. That's good. All the popping on the 1-2 channel switch is gone because that would have been the result of the failed first stage plate supply. I'm sorry, I need a holiday. Plate supply resistor, the plate load is what I'm trying to say. And that would have also been the cause of the scratchy pot on my guitar. The DC present because of the space charge, blah 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 blah. The other thing I'm looking at, which could do with some improvement, is right here you've got your heater lines and you've got your grids right there. So I might put some longer leads here. That lead dress down there is pretty shocking anyway. When that jack's plugged in, these shields have the potential to touch even the tip of that jack, but definitely the tip of the plug. So we could neaten that up a bit, but because there's not a lot of slack on those leads, I'd like to run them down against the corner of the chassis out of the way and get them away from those heater lines, so we'll do that as well. So I discussed the first stage with the owner, and he generally doesn't use the drive setting because it's a little bit harsh, and it is a little bit. So I suggested maybe, because this version's got no bypassing on the first stage, a lot of champs did. I think the very early ones didn't. and then they brought it in at some stage. I'm not sure the history of that, but they brought in a 25 microfarad bypass cap on the V1A. This one's got none, so I suggested if you mainly use it clean, how about we put one in it? Maybe don't have to go to the full 25, but I'll put in a 25 to begin with, just to show him the extreme difference, and then we can change that or play with that while he's here to pick it up. So we'll see how that sounds. So we've got this oversized cabinet with a 10-inch speaker, so a little bit more bottom end. It should be able to handle that rather well. So let's see how we go. Alright, so we've got the 510 ohm in there now. That should help it out a little bit in the valve rectified mode. And notice the other advantage to mounting particularly power resistors on the top of the turret, not only are they replaceable to, you know, fine-tune the bias, that kind of thing, you've got airflow under it now. Previously from the factory, the cathode resist, even though it was 1K and dissipating fuck all, it was sitting against the board there, so there was no airflow around the resistor. Alright, champions, it's go time. We've got it up on the 4 ohm load. Pumping it hard. There you see there, it's starting to level off, 4.5. So for, say, at the start of clipping there, you can see the voltage RMS up to the right, top right. It's about 4 watts clean. However, when you push it hard, it just goes up to about 5 volts RMS when it's hard clipping. That's about 6 watts RMS. So everything's stable and happy. Right, so we've changed to that 510 ohm cathode resistor. Not a hell of a lot of difference. That's brought us to about 115% in solid state rectification mode and about 92% in valve rectified. So we're on the safe side, and that will ensure a long life for that 6v6, but it also won't be choked like the 60% that it was before. So in summary, what did we do, champions? We replaced the grid stoppers there because they were way out of tolerance. The 68 was up around 80k, and 33 was around 40 something. And I've really baffled the next repair guy because we've got a single coax here, which is actually a twin coax. We've got the 2 grid stoppers right there at the pin, and then they come out at the front there on 2 different conductors, shielded at that point. So it's going to confuse the next guy. Sucked in next guy. I've removed that jack. That's a foot switch for the boost, and routed the wire underneath the board there. It's a bit neater and out of the way. Put some heater balance resistors right there on the socket with some free elevation from the cathode there, up to about 20 volts. Replaced the rectifier switch down there with a dual pole, so it shares the current between the 2 poles, and just cleaned up the wiring in that area. It's about as good as we can do given the space restraints, and I've also mounted that. I've elongated the hole to get the switch over to the left a bit more, enough to get a lock washer and another nut on there, so it's not sitting, the shoulder of the switch sitting on that lip in the chassis. So that makes it a bit more sturdy, and just cleaned the wiring up in that area too. Redid the solder connections, proper folds. In this thing, it was either tack soldered or it was wrapped around the terminal like 3 times, so neither one is optimal. You just want a pass and a fold, and then just solder that so it's serviceable in the future. We've removed all the ground connections from all the transformer hardware. Where required, we've soldered it to the chassis down there, past that. It's a bit difficult in such a small chassis to get a good shot. And over here for the safety ground, it's got its dedicated point there. We've rewired the fuse so it's active straight to the tip, and then the ring to the switch to the transformer, and the neutral is coming straight in the blue wire and the cord there, and then straight to the neutral side of the transformer. Just generally cleaned up the wiring a bit where I could as well. Giving a bit more clearance to the chassis lip there for the wiring by folding those terminals over a little. There's a better look at the center tap ground there. Just soldered nicely. Cleaned the flux up afterwards. We've replaced that flimsy little cheap ceramic bright cap with a nicer one, and we've heat shrunk the leads there. Value remains the same, 250 pico. Sounds about right. There's another look at the front end. I've replaced the carbon comp with metal film for the input. All the carbon comps do as a grid stopper in the input is add noise. There's another look at that coax with the 2 cores and the input switching circuit to simulate the plugging into jack 1 or 2. It's selectable with that switch. We've removed the comically large 6v6 bypass capacitor, and somewhat underrated, 25 volts. In its current state it was over 25 volts, so now it's around 20 max, but we've got a 63 volt one in there anyway for a massive margin. But more importantly, it's smaller, so now we can get away from that heat generating resistor. The resistor of which we've changed the value and also lifted it off the board. We've mounted it up in the air on the top of the turrets rather than wrapped around the bottom and making it hard to change and no airflow. Got rid of that dodgy looking bipolar cap that was in there doing the boost circuit. I've lifted it up a little bit just to separate it from everything else. Heat shrunk its leads, got a nice niche con in there. Just mounted it more securely. We've got that little 100k resistor down there, which prevents the popping when you turn the boost circuit on as well. And that 510 ohm resistor on the cathode of the 6v6 has sort of given us the best compromise between the solid state and the valve rectifier setting. And after having a chat to the customer about his use case of this amp and his tonal preferences, we've gone with a 22 microfarad cap bypassing the first gain stage to give it a little bit more bottom end, since the cabinet and speaker is big enough to support it. We've replaced the 2 plate loads there. One was more or less open circuit, 5 meg. The other one had drifted rather high outside tolerance, but was probably going to keep going. The few remaining carbon comps have been tested for drift and they're all within tolerance. We've also replaced the 6v6 there with a Taddy. The old one was microphonic and also jumping around quite a bit in dissipation, so now that's sorted with a replacement. The original 12AX7 and 5Y3 are still viable, so we'll leave them in. Oh, and one other thing to mention, I just put some shielding on the back cover there. Still left a little bit of foam tape that they had there to probably stop rattling, because that will give a positive connection to the chassis in that area and protect it from any stray electromagnetic fields for lower noise. So this is an 8 ohm speaker. It was supplied by the factory and installed by the factory. They even say it themselves here, 5 watts RMS into a 4 ohm load. So we're running an impedance mismatch. This will not be putting out full power. When I tested it on the scope, I tested it at 4 ohms and it was putting out a maximum of about 6.5 ohms clipping into 4 ohms. And when it was clean, it was putting out around 4.5 watts. Now I test sometimes at 8 ohms as well, just to confirm that the power is lower there. When there's an impedance mismatch, you've got a less efficient power transfer occurring, so you'll have less power. And yes, there was less power at 8 ohms, so that is definitely a 4 ohm output transformer with only one winding. There's no other leads other than the single yellow wire coming out of it for the secondary. So I would like to see a 4 ohm speaker in this thing, but running off by a little bit, not the end of the world, but it's just going to cut your power down a little bit, which probably isn't the end of the world with this thing, because people tend to buy smaller amps because they're quieter anyway. Looks like the speaker's giving us the bird there. Well, fuck you too, Celestian. Let's shut up and get this thing back in the cabinet. I feel almost like I've forgotten how to make videos. I feel a bit of a fish out of water after being sick for a while, so bear with me. I'll get my mojo back one of these days. But alright, champions, so I know I said I wasn't going to do any sound samples in this video, but it sounds too damn good now, so I'm going to do a quickie just at the end here. So we've got a self-contained little video of the repair and results of this little bugger. It's really cute. I'm really warming to it again now that all the dumb shit's taken out. Let's have a listen. So there you go, champions. A little bit more than you'd expect to have to address on a what's essentially a champ copy, but nonetheless, I'm quite attached to the little bugger now. It sounds fantastic. Just a quick and dirty sound video. I'll have some better miking and whatever, some more consistent testing in the upcoming video, the comparison with the Tweed Tone 5. So stay posted for that one. And until then, Merry Christmas, Happy New Year, all that jazz. See how many more videos I can fit in this year. Still got about 10 amps to complete in 3 days. So wish me luck. Catch you around.